Hello learner, welcome to Equity Investment Analysis. My name is Emlyn James Ngwiri. I'll be taking you through lesson 2. And what are we going to look at in lesson 2? In lesson 2, we will continue with dividend discount model by looking at the following questions. November 2016, question 1D. May 2016, question 3C. Then we will look at November 2015, question 1B. So let's start by looking at November 2016, question 1D. An analyst has gathered the following information about Surex Limited shares trading at the Securities Exchange. The current market price per share is 22.56. The current annual dividend per share is 1.6 shillings. The annual dividend growth rate from years 1 through to 4 is 9%. The annual dividend growth rate for years 5 to perpetuity is 4%. The annual dividend growth rate for years 5, the required rate of return is 12%. Required. Using dividend discount model, determine whether the shares of the company are undervalued, fairly valued, or overvalued. So the first thing we need to do is to try and identify the inputs to the dividend discount model formula for a two-stage model. We start off November 2016, question 1D. So firstly, the two-stage model for DDM, you're saying is dividend discount model, is as follows. So we have V naught is given as D naught 1 plus GS. I'll be able to explain what the inputs are, over 1 plus R, both power T, then plus D naught 1 plus GS, there, power N, over 1 plus R, N. Then to add the component of perpetuity, we're saying we will be able to add 1 plus GL, there, and then R minus GL, like that. Where V naught is the value of the share, value of the share, like that. Then we have D naught is the dividends. Then we have R is required return, like that. GS is short-term growth rate, short-term growth rate. Yeah. Moving on to this other side, we continue. GL is the long-term growth rate, like that. Any other inputs there? We've actually looked at majority of the inputs, but we've left T, we're saying is the time period. Time period in the high growth period. That N is the time period in the perpetual or in the stable growth period. One thing that I've left out, and I apologize for that, I have left out the summation sign right there. So please just slightly put a summation sign right there. It's supposed to be a summation sign over there. So I'll be able to explain how we'll be able to get the summation sign once we look into the components or the details that have been provided to us in the question. So now slotting in the values, I've already explained what they are, all of them. So we start off by looking at V0 is given us. Now the dividends we've been given there as the annual dividends is 1.6. So 1.6 into 1 plus the growth rate in the short term. The growth rate is 9%, 0.09, like that, over 1 plus. We are saying the required return here we've been given as 0.1 to 12%. 12% is what we've been given as. Then we add now. This is for period 1 there. Now we'll continue like that until we reach the fourth period. If you look at note number 3 there, we've been told that the annual dividend growth rate grows from years 1 through to 4. So we are going to now go like that for 4 periods. So 1.6, 1 plus 0.099 power 2 all over 1, if we can be able to merge this, 1.12, we're saying squared, plus, coming over down over here, 1.6, 1.09 cubed over 1.12 cubed, plus, we're going 1.6, then we go 1.09 power 4 over 1.12 power 4, plus the component of perpetuity based on our formula over there. So we continue adding it down over here. So we say 1.6, we go like that, and we go 1.09. It's just copying exactly what is written over here. And we go power 4 all over 1.12 power 4. Then we add the growth rate in the long term. 1 plus the growth rate in the long term as provided in the question, note number 4, been given 4%. So it's 0.04, like that. Then divided by, now the required return we've been given as 12%, 0.12 minus the growth rate in the long term, which we've been given 0.04, like that. Putting all of those components together, we need now to compute these components separately like that. And I'll very quickly use my calculator with me over here, where I'll be able to get the values. Move over here and write the values on this next piece of board. So we're having 1.6 multiplied by, open the brackets, 1.09. 1.09 equals, divided by, we get 1.12. 1.12. We have 1.55. So come over here and add 1.55 plus, we have 1.6 times 1.09 squared. 1.09 squared, open the brackets, 1.09 squared, like that, equals, divided by, open the brackets, 1.12 squared. 1.12 squared, close the brackets, like that. You have 1.515. 1.5, let's say 1.52, that, rounding off that. Then the third component, we have 1.6. 1.6, you multiply by 1.09 cubed. 1.09 cubed equals like that. Then you divide by 1.12 cubed. 1.12 cubed. 1.47. 1.47 plus, that's the third period. Now go for the fourth period. 1.6, that then multiply by 1.09 power 4, or fourth root, or rather power 4, not the fourth root, like that. Then you divide that answer by 1.12 power 4, 1.12 power 4. How much do we get? 1.44. 1.44. Then we add now this component of perpetuity right down over here. So I'll be able to work it out systematically so that we can be able to get, we do not mix up the brackets. Remember BODMAS? So we're saying 1.6 multiplied by 1.09 power 4, 1.09 power 4, like that. What do we get? We get that. Then you multiply that by 1.04, 1.04. What do we get? We get 2.34. If you can be able to allow me to write somewhere down over here, or besides over here. So we have 2.35, like that. That's what we get, 2.35 there. And then we divide by we get the denominator, we get 1.12 power 4. How much? You multiply that by 0.12 minus 0.04, 0.04, like that. We get 0.13. We divide that by 0.13. You can be able to see 2.35 divided by 0.13. We get what? We get 2.35 divided by 0.13. What do we get? 18.07. So we confidently come over here and put 18.07 like that. So how much is the V naught? V naught is equals to how much? So we say, add that answer. We add 1.44 plus 1.47 plus 1.52. Then we finally add 1.55. How much do we get? We get 24.05. 24.05. That is the value of the share there. So now we can be able to rub what we have computed over here. Now, having looked at November 2016, question 1D, we move on and look at May 2016, question 3C. So May 2016, right here. May 2016, question 3C. What does it say, May 2016? I read as follows. Benson and Benson Limited, BBL, is expected to grow at a rate of 30% for the next 5 years. After that, competition is expected to lower BBL's growth rate to a constant growth rate of 7% per annum indefinitely. The market risk premium is 6%. The risk-free rate is 5%. BBL's beta is 1.5, and the company just paid a dividend of 2.5 shillings. Required, the current value of BBL's share. So this is a very similar question, similar to the one that we've actually done over here, November 2016, question 1D. However, we have to go, the high growth phase has to go 5 periods. Unlike this one where we went only 4 periods, we'll have to go 5 periods. And of course, there are different rates of growth rate. We're saying the high growth rate is different from the one we've actually done previously. So let's look at the formula again. And we are saying the formula is V naught is given as D naught 1 plus GS over 1 plus R. That. Here we have T plus, right there. Saying plus, we have D naught 1 plus GS over 1 plus R. Continuing over there like that, we have a 1 plus GL over there over R minus GL. I'm putting it like that because you need to multiply these two components there. That. Very key thing that we've actually forgotten in our formula over here, just as previously mentioned over here, we need to put the summation sign right there because we are going 5 stages. So now let's look at the inputs. D naught, do we have the D naught? Yes, we have the dividends, 2.5 shillings at the last statement there. Do we have a growth rate in the short term? Yes, the growth rate in the short term, we've been told is the 30%, yes, we've been given right there for 5 years. And then the growth rate in the long term is 7%. Have we been given the component of R? We haven't been given the component of R directly, but we know how to calculate the component of R. We're saying, how do we get R is equals to required return. Notice we have already defined what the inputs are in our previous question, so there is no need for us to go ahead and repeat them there. Let's look at what the required return is all about. The required return is the same as CAPM. CAPM, saying CAPM, is capital asset pricing model. Like that. Capital asset pricing model. Taking the mnemonics, the first component, CAPM, is capital asset pricing model and is a model that is used to derive the required return. What is the formula? The formula is RF plus RM minus RF beta. Moving over to this other side, I explain what the inputs are.
Thank you for watching this video. Don't forget to get yourself a copy of our professionally prepared study text and revision partners. Visit our shop along Tom Mboya Street, Pioneer House, 3rd floor, opposite Fire Station.